Hello and welcome to the section, for those people keeping track, let's call it the section 1.4. Section 1.4 lecture, not 1.5. Miscounting, apparently I can't count. I'm okay with that. And today we're going to be talking about multiplying and dividing rational numbers. So we've talked about adding and subtracting. Now we're going to talk about multiplying and dividing. So something to remember that for multiplication and division, and you don't have this on your paper, you're going to want to somehow create it. For multiplication and division, talking about the signs, right? If I have, that's not going to make sense. If I have negatives and positives involved, I want to talk about what the sign of the answer is going to be. Positive multiplied or divided by a positive will be a positive. Positive multiplied or divided by a negative will be a negative. Positive and negative will be negative, and negative will be positive. Okay? And again, if you want to think about the good thing happening to the good person, that's a strategy that you can use. For decimals, when it comes to decimals and multiplying and dividing, I only have one big key. Use a calculator. As I talked about yesterday, calculators are made in a decimal system. So use them, right? Use that calculator. Where'd that go? Right there. So use your calculator to help you out, and it's only going to make your life better. Okay? So if I have 2.48 times 5.34, and I'm going to put most of the decimals on there on problems like this. Most of the time when I'm multiplying, if I add up the number of decimal places, that's how many decimal places my answer will have. So we get 13.2432. Okay, this one's probably also going to have 4 decimal places. I can't really I can, but not as easily. I can't do negatives that well on this calculator. Yeah, this button's here, but I have to put the number in and then hit the negative. I don't waste time with that. I just know that since it's a positive and a negative, my answer is going to be negative. So negative 18.3936. This one's a division problem. A negative and a negative, so I know my answer is going to be positive. So 7.254 divided by 3.14. And I probably won't have to write all these decimal places. Stick somewhere in between what your two problems had, and we can just round it to that. So I'm going to say probably 2.310. 2.310. Okay, if you want to throw the other one on there, that's okay. But definitely rounding needs to be involved. Let's see, 15.371, another division problem, and 8.3158. Again, we'll round, maybe use 3 to 4 digits, whatever kind of seems easier. 8484, and that sounds good. 1.8484. Okay, and that'll be that. Awesome. So multiplying and dividing decimals, use a calculator, use the tools that are at your disposal. They can be done by hand, but they're never an easy task. It's just time consuming, and I'm not really testing you on how much time it takes you. I just want you to get the problems done. When we're talking about multiplying and dividing fractions, on the other hand, and mixed numbers, I guess, The important things to follow are, well, the reason we need a way to do these by hand is that calculators don't handle fractions very well, for the most part. There are calculators out there that can do fractions very neatly and very easily, but even some of the more advanced calculators don't do that very well. So we want to find a way to do that part by hand, because also it is quicker. The first thing we always want to do is we want to check for any mixed numbers, and we want to go mixed numbers to improper fractions. So mixed to improper. And then for multiplying, that's what we're focusing on right now. We want to multiply straight across. Ooh. Okay. Multiply numerator times numerator, denominator times denominator, and you're done. Well, maybe talk about simplify possibly. Because you'll end up more so in multiplying and dividing with fractions that can then be simplified, as opposed to when we added and subtracted. It'll just happen more. So I don't have any mixed numbers. Okay, multiply straight across. 5 times 5, 25. 6 times 6, 36. Done. Multiplying fractions is really what we wish adding and subtracting looked like. Just turns out that this is just easier. There's no real way around that. I didn't mean to say simply. Simplify. This one here I have negative 1/2 times 5/8, so 1 times 5, and I always kind of tag this negative as part of the numerator, so I'm saying to myself negative 1 times 5 is negative 5. 2 times 8 is 16, and we're done. Okay. Next one, I have some mixed numbers, so I'll turn those into improper fractions first. Same way, denominator times whole number plus numerator. 5 times 1 is 5 plus 4 is 9. 9/5 times 2 times 3 is 6 plus 1 is 7 halves. 9 times 7 is 63, and 5 times 2 is 10. Leave it as is. It can't be simplified. Next one, I have a couple mixed numbers here. Well, a mixed number and a whole number. 15 times 2 is 30, times 1 is 31, and I need to make that negative. 31 halves. In this one, I'm just going to leave as negative 3, but I'm going to put it over 1 so it looks like a fraction. That is the same number, but now it looks like a fraction. Let's see, what can we do here? Negative times a negative is a positive. 31 times 3 is 93. 2 times 1 is 2. So it looks like a tough problem. It's actually pretty quick and easy. Okay. I mean, that one wasn't totally easy. We had to think about 31 times 3, but other than that, it wasn't too bad. Next one, I have a negative and a negative. I don't have any mixed numbers, so I can go ahead and just multiply straight across. Negative 3 times negative 7 is going to be positive 21. And 11 times 11 is 121. Now, I don't get to cancel out those 21s. And in fact, they are, that's as simple as that's going to get. Okay. Next one, negative 4/9 times 2/3. Negative 4 times 2 is negative 8. 9 times 3 is 27. And we're done. Again, we really wish more things were like multiplying fractions. It's really nice. 2 times 4, we got to turn this into an improper fraction. See, my brain just starts doing it. 2 times 4 is 8 plus 1 is 9. Times, we have a negative here, but it is over 6. 6 times 1 is 6 plus 5 is 11. And now we can go at this problem. 9 times negative 11 is negative 99. 4 times 6 is 24. Now it turns out that these are both multiples of 3. Okay, they are. So I can divide them both by 3. The top becomes negative 33. The bottom becomes 8. And that's as simple as it'll get. Now, if you remember from way back in the day, you can do a thing called cross-reducing. Okay? I knew that they were both multiples of 3 right here. I could divide that 3 out right now. If I take 6 divided by 3, that turns into a 2. 9 divided by 3 turns into a 3. And now we see 3 times negative 11 would give me that negative 33, and 4 times 2 would give me that 8. I would encourage you to look for any cross-reducing as you work through the problem, because it will make your numbers smaller, and it'll just be nicer. So hot alert, it's probably going to happen in this problem. Turn this one into an improper fraction. 4 times 1 is 4, plus 3 is 7 fourths times 4 over 1. Hey, look, I said beware. That's coming. Those are both multiples of 4. So when I divide 4 by 4, I get 1. 4 by 4, I get 1. Now this problem became super easy. 7 times 1 is 7. 1 times 1 is 1. We don't have to write 7 over 1. We can just write 7. Also notice if I didn't realize that and I accidentally went ahead and just started multiplying, I would have got 7 times 4 is 28. 4 times 1 is 4. And then I could have realized that 28 over 4 will reduce to 7 over 1. All right, let's look at the next page. Here we're talking about dividing mixed numbers and fractions. I still want to keep my same first step in that I still want to go mixed numbers to improper fractions. And then I want to, I don't like dividing fractions, let me say that, okay? And this all comes from the idea that I think the easiest thing to think about is if I divide something by 2, if I say 10 divided by 2, okay, that's 5. It turns out that I get the same thing if I take 10 times 1/2. I still get 5. So dividing is the same as multiplying by the same fraction or the same number just flipped over. Okay, and for that we talk about, there's probably been a class that said something like keep, change, flip. And what they mean by that is keep the first fraction by itself, change the division to multiplication, and flip the second fraction. Okay, then we should always check if we have to simplify. Okay, so mixed numbers, yeah, I got one, so let's get to that. 6 times 1 is 6, plus 5 is 11 over 6. Again, I don't want to, and we almost never, okay, we never divide fractions. We keep the first one, change it to multiplication, and flip the second one. And then I do notice that I have two numbers on the top and bottom that are multiples of 2. Okay, 4 divided by 2 is 2. 6 divided by 2 is not 2. Nice try. How about 3? So that can help me out and make it a little bit less work when I go to multiplying. 1 times 3 is 3. 2 times 11 is 22. And we're done, and we don't have to worry about simplifying because we already did it. Okay, next one I have 3/4 divided by -4/1. Keep the first one, change it to multiplication, and flip the second one. Now, I know flipping that -4 is going to put a negative down here. It doesn't matter, though. I can think of it as part of the numerator. That works for me a little bit better. I like thinking about that negative as part of the numerator. 3 times -1 is -3. 4 times 4 is 16. There was no reducing that we got to do early, so there actually isn't any that we get to do late either. Let's see, this one we have a negative. It's going to be over 5. 5 times 1 is 5, plus 4 is 9. Divided by, this is a negative, it'll be over 2. 3 times 2 is 6, plus 1 is 7. So I have -9/5 divided by -7/2. We're going to keep the first one, change the operation, and flip the second one. And there's no reducing that we get to do. Got a lot of prime numbers there and one composite number, but it's not a multiple of that, so we're good. Multiply straight across. 9 times 2, -9 times -2 is positive 18. 5 times 7 is 35. And there we go. What about this one? The trick with this is realizing what it actually says. This is what we call a complex fraction. It's really just saying 1/3 divided by 3/7. Now it's a little bit easier to do. It looks like the other ones. Keep the first one, change the operation, and flip the second one. Multiply straight across. 1 times 7 is 7. 3 times 3 is 9. No simplification needed. We're good to go. Go ahead and pause the video and try these last 4 problems. Hopefully you had a chance to do that. Let's go ahead and take a look at how you did. Change this to an improper fraction. Divided by 5/4. Keep, change, flip. Cross reduce because I can. 3 times 1 is 3. 1 times 5 is 5. And we're done. On this one, a lot of times I'll just put an over 1 right there so I don't have to write more. I can flip this fraction now. No cross reducing to happen. 2 times -1 is -2. 5 times 7 is 35. Now we've got a couple mixed numbers on this one, so we'll go ahead and rewrite those. 10, 13. And we've got 6, 18, 23, -23. I don't know why I said plus, that's divided by. Keep, change, and flip. 13/5 times 6/23, -23. Let's put the negative up top. No easy way about this one. Nothing reduces, which I wish it did. but we should get, what, 60, 78? And 15 and 100. So, what did I say? 115. There we go. This one, always easier to rewrite it as division first. Okay, then we keep, change, flip. You got some cross reducing. 3 turns into a 1. 3 turns into a 1. And so we have 2 times 1 is 2. 1 times 5 is 5. And that is it. Okay, so check your work on those ones. If I could pause it and have it done ahead of time, that would save a little bit of time, but that's okay. Anyways, make sure you write down any questions that you have about this and get those answered in class. Otherwise, I hope you have a great day, and we will see you in class.